All right, welcome back to Blueprint 101. We're on Section 3, Unit 1, Engineering Drawings, Understanding Engineering Drawings. So we stopped last time here on line types and our descriptions. We're going to pick back up and start from the top to the bottom. This starts in your book on page 208. And I highly recommend that you know these lines fairly well. They can be rather confusing. And there's quite honestly, there's times that I will always have to revert back to like a phantom line or something like that. I can usually figure it out for the most part, but occasionally I'll have to say, if I've got 2 or 3 broken lines in there, I may have to look back and say, what does that mean again? So forth, okay? So when we talk about successful note taking again, this is something that I would possibly draw in my notes, because remember, most of our tests are going to be closed book but open notes. So if these are in there, you can use them to be able to tell you this is an object line, hidden line, center line, dimension lines, and so forth, okay? All right. So top one, solid line, is the object line. Object or visible lines are used to show part edges. They're visible in a given view. They're thick and continuous. So here we are. You can see that the outside of this part, got a whole bunch of lines in there, right? The outside of this part is drawn with object lines. Okay? These are not object lines, these are dimension lines. So, however, they are solid lines, but they are dimension representing that dimension as well. Okay? Anytime you can see a solid object line, especially from this direction, you know you should be seeing an edge. So in this case here, this is a hole. We are seeing the edge of the hole, so we know that the hole is going in this direction from the top side, since this is a top view. Okay? Now imagine if we laid that down, that makes perfect sense as far as our hidden line here, that we would be seeing the object line on the top, but we can't see it from here, from the front view. Sorry, I'm trying to zoom in so that we can lay these prints out the best we can. Okay. So we've got object lines. I think we understand what they are. Okay, let's go back real quick. Hidden lines show part edges that cannot be seen in a given view. They are thin and broken into small dashes. So these are hidden lines. So here's what we just talked about. Right here on the top right, or the bottom right hand corner of that part, on the top view, we had the hole, right, represented by C, or the same area that C is going to. So the outside diameter. Now we're going to bring it down, and we're going to show it into hidden lines. So now there are hidden lines, since we cannot see it, but we know it is there and it should be represented there as well. Okay? So this is our diameter. But up here we noticed that we had two dark lines, and if we look at this print in great detail, we can see that it's been chamfered on the edges as well. Okay? Another example up here, you can see the 3 small holes on the top view. Your top one there, middle, left-hand view. Down here are hidden lines on the left-hand side, showing the 3 different representations of holes as well. So, I want to take 1 second, and I want to show you real quick between the 2 of these. So what we can see is we have a solid block on the top I'm gonna take it and bring it over here so you can actually see what I'm drawing. So now we're trying to give it a three-dimensional point of view, okay? What am I missing here, Dan? I think that is here. So we have here, come across here, okay? And then you can see that we step down on these four, right? Broke that down, then we come out. Center to here. So that's just one step down, two steps down. Okay. From this side, it goes all the way down. Straight forward. We continue down. Continue down along this section. A little bit forward. We have one more step, correct, Dan?
Mm-hmm.
Again, this isn't to scale. Thank goodness. Okay. So what we were doing there on that drawing alone was just trying to explain. I did a three-dimensional drawing, an isometric drawing, I'm sorry, off of just the top two to start with. Okay, so on the bottom side we can see right here that we have this hidden line, but on the top we don't have any hidden lines. Okay, so the top, when I come over here, my hidden line from the side is actually what I'm seeing here, but from the top side it's a solid line. Okay, so now we're able to take and do this drawing and place it in an isometric view, give it 3 dimensions so that we can understand what this print should look like in that view by just the 2-dimensional view. Okay, most of the time you're going to get this as well, but occasionally you won't. Part of your skill assessment here in the shop may simply be that you need to make this 3-dimensional part off of a 2-dimensional piece. Okay, and then here on the right hand side we would be showing the front view. Okay, all right, so let's go back. We've got object lines and hidden lines done. The next one is going to be a center line. So they show the center of a diameter or radius, or the center of a part. Hole locations are shown where 2 center lines cross. They're thin and broken into alternating long and short dashes. Okay, so long, short, long, short. Okay, let's see what it looks like on a print. So just the hole alone, it's represented by C. There's the center line on the right hand picture of our large hole. If you look over here to the left, you will notice that all 3 of these holes also have center lines along with their hidden lines representing the the outside edges of the diameter. Okay. Dimensioning line. Let's do dimensioning lines and extension lines, okay, and leader lines. So extension line is number 5. Number 4 shows the dimension in between. Look at those two first, okay? So number 4 is the dimension line. Number 5 is the extension line. Right there in front of us, the 2.50 on the top side is a good example. Your extension lines are extending up beyond this part, so that way you are able to still see the full view and detail of the center part, okay? Because if we put all these numbers in here, if we put everything in this block, then we would not be able to see the details within the part. So we have to use extension lines to come up, and then we use dimension lines to give us the actual dimension with the leader arrow showing which part. So these ones are an internal dimension line inside of extension lines. Scan up here to the 0.250. And you can notice that these are dimension lines that are showing the dimension within the extension lines. So we're showing from the center of this bolt hole to the bottom edge. But instead of being internal, we'd have to come out here and the number wouldn't fit. We print the number inside and our leader arrows are pointing to the actual dimension. Okay? All right, I think we got the gist of that. Practice some more on those. We also showed leader lines. Let's go back and show another good example. So for example, real quick, this hole to start with, the leader line is showing our dimension to this object. So our diameter is 0.750 plus or minus 5 thousandths. So it can be 0.7555 or 0.745 is your allowable tolerance, okay? So I think we're at the point where we're going to start breaking down a little bit of the feature frames, okay? So let's look just inside of the feature frame itself. This one example shows the crosshair looking piece is a position. The position, the diameter has to be within 0.008, 8 thousandths of an inch. Okay? So, what that is talking about so let me write it down here real quick and then we'll draw it on the board. Okay? Sorry. So we have a diameter hole. It tells us it's 0.750 plus or minus 0.005. Feature frame tells us position, diameter-wise, 0.008. Okay? So let's talk about this real quick. So it's telling us that this hole can be plus or minus 5 thousandths of an inch. So what it's saying is that this can be anywhere from 0.745 0.755. Okay, that's the allowable limit within it. Now, to say this ends up being 0.747, and then this dimension ends up being 0.753. Is it within tolerance? It is. Okay. It's ovaled. We know it's ovaled, but it's within tolerance of what it's stating. What it's showing us here is that the center, the position, has to be within 0.08 of an inch. Okay. So this is just giving us the outside dimension. What this is saying is that the center dimension has to be within 0.08 of an inch. Correct, Dan?
Correct.
So now we have an outside tolerance, but we also have a tolerance saying that it has to be within 0.08 of an inch of the diameter, the center. So if our center portion, naturally we'd think it's here, but if our center of our diameter of the hole was here, we'd be out of spec. Okay? We want to make sure that that's right where it needs to be. Center should be directly in the center, always naturally, but we can be off 3 or 4 thousandths on that as well. Okay? I hope that makes sense.
Can we go back to that print?
Yeah. Hold that down.
So you can see here that these external dimension lines, this is a 1/2 inch to center, and it's 2 inches from this edge over. That's where you can get off over that 8 thousandths if you're not zeroed up on your part. That's how that happens.
So what you're saying, Dan, is that it's easy, you should always work from one edge, right?
Correct. I like to work from the datum line. Wherever the engineer is set up his datum line, I'm going to follow the same path that he drew it in.
Okay. So in this print here on the top view, how do we know where the datum line is? So what we're going to look at here is, to start with, you notice at the end of that feature frame, it gives you a primary datum line. Your first one is A. Okay. So your A, it's come down here to the bottom section of this print. Your first datum line is this corner, these two corners right here. Okay. Backside in this. Secondary datum line is your C. Sorry, I'm off here. I'm reading the wrong stuff. Our first datum line is A here. Secondary datum line is C. No, I'm right. Right? Dan was looking at me a little goofy there for a minute. I had too many things going through my head right now. So let me find my C datum line. It's over here. So it's the back part of that edge, left-hand side. You're seeing it on the extension line there. So that kind of goes with what Dan was saying. That's your 2.50, right? And then your third section of your datum line here within the feature frame is D. So now from that portion, let us find D as well. There's D on this corner, okay? So let's come back over here and let's represent that in a geometric shape, okay? First things first, our bottom datum line is this bottom piece. That's A, okay? That's what it showed us over here. Next section is going to be C. It's the back side of this piece. This plane going in this direction. See? Then your next datum line, which is D, it shows is off of this edge. So this piece right here, this side, is D. So now we have an X, Y, and a Z axis. If we were talking about it in that direction, okay? If we're looking down on this part here, this is one axis. Our hidden line should go across, tie in here. Here's our other axis, which is C, our datum line for it. And then our Z axis for depth, looking down on this, is D, going from here to the top. Okay? So what I want you to do is I want you to work through a couple of these prints in the book. Start looking at where your datum lines are on your own. Come back through this. We are going to finish out the rest of these lines. Number 7 is your cutting plane. Used to make an imaginary cut through an object. The arrowheads indicate the viewing direction of the section view after the cut. They're thick and having one long and two short dashes alternately spaced. I don't see any cutting lines on this. Our datum lines are on the outside edge. We will find it later. Section lines, I did not see any section lines on this one either, showing a cross section of a pattern. Phantom lines. Let's see if we can't go to a print and find us some. Here we go. So here's a phantom line. Okay. Some people say this is your actual piece of stock. So, real quick, here on the side, if you notice on this left-hand side, there is not one. You can look through the PowerPoint at the same time. You'll see our phantom line going across the top there, and there it's referenced stock in the top right corner of it, coming back down as well. So when we look at this, we don't know exactly what we're dealing with, but we know that dimension has to be 6 inches even. Okay, so the first thing we would do is we could straighten up this left-hand side, square it up, these bottom two sections, since those do not have any phantom lines on them. We would want to square off, make sure that this is perpendicular here, and then from there, this is our measurement point. Okay, this is our datum lines, is where we would start. Because we know that these are machined correctly to begin with, then we can start doing the rest of our layout in that fashion. Correct, Dan?
Correct.
Okay. So if we look at it on the right-hand side,